Okay, let's start. All right, so last week we ended at creating raster maps. Okay. Today we are going to more of the indices and then temperature analysis. And then tomorrow we will look at the steady area map creation. So basically today we are going to look at how to calculate normalized difference vegetation index, which is NDVI. And then we also look at how to create normalized difference water index, which is NDWI. And then lastly, we look at how to do temperature. That is land surface temperature to be precise. We are going to look at how to calculate them in Landsat. And then we move on to the creation of the maps, which is tomorrow. So when you open the file I sent you, this file, okay, so this is for the Normalized Difference Vegetation Index, which is the NDVI. And then this is for the NDWI, which is Water Index. So when I'm done with these calculations so today we'll be using both ArcGIS and ENVI. Okay, we are going to switching them. And then from there, we'll move on to temperature analysis, which you are going to use this formula in the ArcMap. You don't need to calculate it. We are just going to use the formula in the ArcMap to perform this, as well as use the metadata components to derive at our land surface temperature. Okay, so this is what we are going to do today. So first, we are going to start with the Normalized Difference Vegetation Index. I'm sure most of you have heard of NDVI before. All of us have heard about NDVI before. So basically, this NDVI, as the name depicts, is for vegetation analysis. So if you want to look at the health of a vegetation, particular area, region, or a country, you can use NDVI. And there's another one called EVI. That one is Enhanced Vegetation Index, which is also useful in looking at the health of vegetation. But we're going to look at only NDVI today, which, as I said, is used to assess the health of the vegetation. Okay, mostly NDVI values lies between -1 and +1. The closer it gets to +1, that means the vegetation in that area is very healthy. The closer it gets to -1 means the vegetation is unhealthy or it's not vegetation at all. Okay, so we are going to look at how to calculate these indices, and then we look at the water indexes as well, which is the NDWI. Same application. So the closer it gets to 1, that means the water is quite insignificant in that area. The closer it gets to -1, water is insignificant, there's no water at all. Okay, so that's what we're going to do. We're going to use both ArcMap and ENVI to do that. Okay. So let's start with NDVI. Okay, this is supposed to be VI, not WI. It's supposed to be VI. Type error. This is VI, not WI. Okay, so we already have band 4, right? We calibrated band 4 the last time, right? But we don't have band 3, right? We don't have band 3. We calibrated band 4 the last time, but we don't have band 3. But with the formula for NDVI, it's what? Band 4 minus band 3 divided by band 4 minus what? Plus band 3. In other words, near infrared minus red, near infrared divided by near infrared plus red. Okay, so the near infrared is what? The band 4. The red is band 3. So whenever when we did the layer stacking, you can see that you have red, green, and then blue, right? So the red in there represents the band 3. Okay, but we didn't do band 4. Okay, we didn't do band 3 when we're doing the calibration. Okay, so I'm going to give you 15 minutes to do band 3, and then for NDWI we had band 2, right? But we didn't do band 5, right? Yeah, so I'm going to give you 15 minutes, or okay, so 20 minutes. I'll give you 20 minutes to do band 3 for Landsat 4, and then, sorry, for Landsat 5 and Landsat 7, and band 5 for Landsat 4 and Landsat 7. Is it clear? I should repeat it again. Okay, so I'm saying that last time when we're doing the layer stacking, or when we're doing a calibration, remember we calibrated band 4, right? But we did not calibrate band 3, right? So today we are going to calibrate band 3 for Landsat 4 and then Landsat 7. We calibrated band 2, right? But we didn't calibrate band 5, right? So we are going to calibrate band 5 for Landsat 4 and then band 5 for Landsat 7. Is that clear? Or I should repeat again? It's clear, right? Yes, so this will test that whether you are actually doing your revisions on it. So we are going to calibrate this one. So I'm giving you 20 minutes to calibrate band 3, Landsat 5 and Landsat 7, and band 5, Landsat 5 and Landsat 7. Okay. I'll be doing it along with you, but I'll be much more faster. But because we've done this already. Okay, so 20 minutes, it's now 9:15. So 20 minutes the next 20 minutes will be done, right? So you can start now, because in the next 20 minutes we will move on to the calculations. So you can start doing the band 3 and then the band 5. And when those who don't have it, when I'm done, I'll put all of them in the group. Those who don't have it. Okay, I've sent both the 3 and then the 5 in the group. So those who are having issues can download it. But if you've already done it, we can just continue. We spent like 30 minutes on this. So and we are about to start what we are supposed to do today. So we need to get a bit fast. Okay, so you can launch your ArcMap now so that we start with the calculation of the indices. So as I mentioned earlier, we are going to first look at NDVI, okay, where we can see that NDVI is equal to near infrared minus red, which is band 4 minus band 3, all divided by near infrared plus red, which is band 4 plus band 3. Can we continue? Yeah. It's downloading. But I thought you were also calibrating. Okay. So you just download and let's continue. And as I mentioned earlier, for band 4, we already have band 4, which we did from the beginning of the course. We already have band 4 and band 2 already, so we just calibrated band 3 and band 5. Are you done downloading it? I think the file size is not that big. I think one is 51, 52, and then one is almost 60 gigabytes. Let me give you like 2 minutes to do that. Are you done? Are you done? Okay, let's continue. All right, so we are coming to start what we are supposed to do today. As I said, the indices, which we are starting from NDVI. So as I said earlier, NDVI is basically analysis which is done to check the health of the vegetation. NDVI values lies between -1 and +1. The closer the value gets to +1, it means the vegetation in that area is very healthy. The closer it gets to -1, it means the vegetation there is unhealthy or it's not vegetation at all. So that is what we are going to do. And this analysis is basically very important to those who are into forestry. The geology too is also it's also there. Those who are into carbon pools or carbon sequestrations and other stuff. So basically it helps you to understand if the vegetation is quite higher, that means these trees are able to absorb carbon in the atmosphere just to reduce this ozone layer depletion. So it's very useful in these studies. So we are going to perform these stuff. All right, so to do that, first you need to bring the two images into ArcMap. Okay, you need to bring the two images into ArcMap. All right, so let's bring those two images into ArcMap. So I'll just go to the add data file. And I'll navigate to where I saved those files. Okay. So I'll go to the add data file and I'll navigate to where I saved those files. Okay, so we are going to bring band 3 and band 4 for Landsat 4. We are going to bring in band 3 and band 4 for Landsat 4. All right, so let's just drag them in because it seems the add data is not able to capture them. Okay, so when you open to band and the Landsat 4 folder, okay, the calibration, okay, you select band 3, which is this one. Okay, you select band 3, and then you hold Control, and then you select band 4, calibrated band 4, like this. Okay. No, Landsat 4. Landsat 4. So we are selecting calibrated band 3 and then calibrated band 4. Okay, for Landsat 4. Landsat 4. Okay, Landsat 4. For Landsat 4. Then you drag them into the ArcMap like this. So to actually, sometimes actually just select yes. You are just bringing them into the ArcMap. So band 3 and band 4. So once you load them, you are going to see that both of them have appeared here. The calibrated one, please. The calibrated one. So you have cow band 3 and cow band 4. You have cow band 3 and cow band 4. You just go click on them and then drag them into ArcMap. Okay. So you have in the layer manager, you see cow band 3 and then cow band 4. Do we all have that? You are just loading them into the ArcMap. It's Landsat 4, LT4, calibrated band 4 and then band 3. We are just loading them into the ArcMap. That's what we are doing. Is anyone lost so far? Yeah. So I named one L4 and I named one L7. So L4, that's what we are loading here. Band 4 and band 3. Yeah, the 4 we did calibration from the start already. So you have to just bring the 4 in here. The one that we didn't do, that's why I gave it to you. So okay, let me send you the band 4 just in case those who were not here. So I'm sending the band 4 too. I'm sending the band 4. Because I thought we already did that last 4 weeks or so. Let me send the band 4. I'm sending the band 4 to the group. Come again. Yeah, band 4, you can load the previous one, yeah. Yeah, same one. The reason why I didn't add the band 4 because I thought you already had it. Because last time we did it, yeah, in the previous class we did it. But I'm sending it to you again. It's fine. I'm sending it to you again. So I've sent the band 4 for Landsat 4. I'm going to send the band 4 for Landsat 5 now. For Landsat 7 now, sorry. Okay, so now I've sent both of them. So we are dealing with only the Landsat 4 image. Okay. Yeah, I've sent one for Landsat 7 and one for Landsat 4. Okay, so you load calibrated band 3 for Landsat 4, calibrated band 4 for Landsat 4. Okay, so I indicated L4. L4 means Landsat 4. So use the one with the Landsat 4. Okay. Let me repeat again. So we are doing this, okay? We are doing NDVI and we need band 4 and band 3, right? We already did band 4 long time ago, okay? So I only sent band 3 and band 5 because we didn't have those ones. So now send band 4, okay? So you load in band 4 and band 3 for Landsat 4, okay? I named it L4, okay? L4, okay? So you are going to locate Landsat 4, okay, calibrated L4. That one hosts 3 and 5, okay, and this one hosts only the 4. Okay, so you bring 3 and 4 into ArcMap. That is all I'm saying. For Landsat 4, 3, band 3 and band 4. Let me see if the size, I don't think the size is that big. Okay, it's 24 and 27. Okay. So when you're done downloading, you bring them into the ArcMap. Can we continue? All right. So now you've brought them into the ArcMap, right? So the next thing to do is to perform the NDVI. Okay. So now I'm going to perform NDVI. So first, let's divide them into two. So you're going to do this first, and then we do that. Okay. So the first one is what? Band 4 minus what? Band 3. Okay. To do that, we need a tool called the Raster calculator. Okay. The Raster calculator, which is basically for doing math in the ArcMap. Okay. Doing math in the ArcMap. Consider that it's more of what? A math equation, right? So band 4 minus band 3. Okay. As I said, band 4 represents the near infrared, band 3 represents what? The red. Okay, so now let's do that. So we have two ways of doing that, of getting a raster calculator. We have the long process and the short process. Okay, so let's start with the long process. So if you want to locate the raster calculator, okay, you go into your toolbox. Okay, the toolbox is located. If you don't see yours here, okay, it's located up here. Okay, up here. Okay, the Arc toolbox. Okay. All right. When you click on it, it's going to display something similar to this. Okay, so in the Arc toolbox, there's a tool called Spatial Analyst tool. This tool. Okay, Spatial Analyst tool. You expand that tool. You expand that tool. You expand Spatial Analyst tool under the Arc toolbox. You expand it. When you expand it, it gives you something like this, right? Okay, so you have a whole lot of tools in there. Okay. You see map algebra, right? Map algebra, another M column. You expand that one too. Okay, you expand map algebra. So when you expand it, you see what? The raster calculator in there, right? You see the raster calculator. Okay, under math algebra, you see the raster calculator in there, right? You double click on it, which gives you something like this with the band 3 and band 4 already displayed in there, right? Okay. Should I go back or I should continue? All right. I'm repeating again. After loading in your band 3 and band 4, okay, you go to your toolbox. Okay, the last but 3 tool, another toolbox is called Spatial Analyst Tools. Okay, you expand the Spatial Analyst Tools. Okay, and you see some bunch of tools in there, right? All right, so another bunch of tools, you are going to select Map Algebra, this one. Okay, Map Algebra. You expand it. Under it, you see what? Raster calculator in there. Okay. All right, so you open that raster calculator, which gives you this dialog window, right? With your band 3 and band 4 displayed in there. Okay. Alternatively, you can go to your search tool. The search tool is located in here. Alternatively, you can go to your search tool, which is this one, in here. Search tool, this one, this small in there. Okay. Okay, you go there, and then you type raster calculator. Okay. As soon as you hit enter, it gives you what? The raster calculator in here. Alternatively, it gives you the raster calculator in there. So when you select it, it gives you the same window we opened earlier. Okay. All right. So now let's move on. So the first instruction is to what? Perform what? Band 4 minus band 3. Okay. To do that, in the ArcMap, you what? Bring your bracket. You can see that there's a bracket in here, right? Bring your bracket. Okay. This one, the bracket. Okay. This. Bring your bracket. And then it says 4 minus what? Band 4 minus band 3. You double click on band 4, which appears down here. Okay. You double click on band 4, which appears down here. Okay. The next one is what? Minus, right? So you select minus in here. And then double click on what? Band 3. And then you close the bracket like this. Okay, so you bring your bracket, your open bracket, you double click on band 4 minus band 3, you bring your close bracket. So now you're done with the first step. Okay, this is quite easy, right? It's quite easy. Now, divided by, according to the equation, it says what? Divided by, okay, band 4 plus band 3. Okay, so you bring your divided by sign, which is this one in here. Okay, the divided by sign, which is this one. Okay, and this time it's going to be band 4 plus band 3, right? So you bring your open bracket, you double click on band 4, there's a plus sign somewhere here, and then band 3, like this. So you have something like this. So it says NDVI is calculated by subtracting band 3 from band 4, or divided by adding band 4 and band 3. Okay. Any questions so far? Any questions so far? So when you're done, you just click OK. So it runs the Raster calculator, and then when it's done, it gives you the results. So sometimes it will take some few minutes to do that, depending on your computer specs. Okay, so you can see that the values that appear there is between -1 and +1, right? Those who have done it, or it's still loading. Right, so the value that one gives you what? Between what? -1, the high, and the lowest is what? +1, right? So what did I say the +1 represents? That means the vegetation is what is much more healthier. And the -1 is unhealthy, right? All right. So now we want to choose a vegetation color, right? We want to choose a vegetation color. So we can click on this icon. Okay. You can click on the icon just at the side, this icon of the image, this icon. You just click on it, this icon. Okay, this color ramp, you just click on it. Then it gives you color options. Okay, so you can select any of the color options which suits vegetation. So let's say if I want something like maybe this, any of them is fine. I'm just choosing any. Okay, and I click OK. You can see that the highly vegetated areas have, the color ramp shows what? The high vegetated areas, the less dense vegetated areas, and then the no vegetation at all. Okay, or very unhealthy vegetation. So you can see that the water body parts are more closer to -1, which means they are not vegetation at all. But this side and this side are closer to what? 1. So that means they are vegetation. They are healthy. The vegetation here is much more healthier than the vegetation here. Then you can choose any color ramp if you present any color ramp. You can choose any of the color ramp you want. Okay. You can choose any. I can choose any of the color ramp I want. I can change this to maybe something like this. Okay. You can choose any of them. You can choose any of the color ramps which you feel suits vegetation. All right. So this is how we perform NDVI. However, if remember we are dealing with a steady area, okay? We're dealing with a steady area, which is the Accra metropolitan area. So if you want to know the NDVI of Accra metropolitan area, what do you do in this case? Because this is the whole of part of the coastal region of Ghana. So if you want to look at only AMA, what do you do? If you want to look at only AMA, what do you do? If you want to look at only AMA, what do you do? You clip AMA. It's a raster image. You don't clip raster. It's a raster. What do you do? What do you do? Yeah, you first overlay, right? So after you overlay, Okay, so let's overlay the AMA. Let's overlay the AMA. You already have the AMA, right? So let's overlay the AMA. Let's overlay the AMA. I think last time I sent you the AMA, right? In our last meeting, I sent you this file, right? The AMA, this file. I sent you this file, right? So you are using that file, this file. Yeah, so I sent you this file, right? The last time I sent you this file. So we just want, let me make it more distinct. We just want this area. We just want this area. We just want this area, right? Okay. The AMA I sent you last time. It's in the group. I just said this. Oh. Okay. All right. So as I said, we load in the AMA. Okay, just drag it into it like this. You just load the AMA like that. Yeah. The reason why I just jammed it because we did it, we've done it several times last weekend beyond. So just want this area. Just this area, right? Our area of interest is AMA. Okay. So we need to what? Extract. Okay. So we call it in Raster, we call it extraction. If it's a vector, we call it clip. Okay, as Ishmael rightly said. Okay, so we need to extract this area, okay, to see the NDVI values of the area. Okay. So to do the extraction, you still go to your toolbox, the shortcut. There's another same tool, the spatial analyst tool. This time you are going to, you see extraction in there, right? Extraction for the E column. Should I repeat the steps again? Okay, you bring in your AMA file, the one I sent you some time ago. Okay, you bring in the AMA file. Okay. Come again. I'm just repeating the steps again. So you bring in the AMA file. Okay, the AMA shape file. Okay, so it displays like this on it. Okay, you can choose to change the color, right? You can make it hollow. Okay, you can make it hollow, like how we did last week. I'm just repeating what we did last week. Okay, and then you can see that it has been overlaid there, right? But we need to what? We need to extract only this area. We don't want the rest of the areas. Okay, to do the extraction, under your toolbox, the same tool, spatial analyst tool, you expand it. The fourth option, which is extraction, this one. Okay, the fourth option, which is extraction. So the same under spatial analyst tool we opened. 1, 2, 3, under extraction, you expand extraction. So when you expand extraction, you see a tool called extract by mask. This one. Extract by mask. Which is the third tool under extraction. Extract by mask. Do you see that? Yeah, so you double click on it. So first you load in the AMA, okay, shape file. Secondly, you go to Spatial Analysis Tools, okay. Under Spatial Analysis Tools, you select Extraction. Under Extraction, you pick Extract by Mask. Extract by Mask, which displays this dialog window for you. Can we go on? Can we go on? All right. So the next thing to do is that it's asking you that what is the input file, right? So the input file is going to be the whole of the NDVI image. Okay. The input file is going to be what? The whole of the NDVI image, which is this image, raster calculator, the raster cal there. So in the input file, it is the raster calculator, the one that you just performed, which is the NDVI. Then the input raster of the feature max data is the AMA. Okay, so you select AMA, this. Okay, AMA. Okay, I'm repeating the steps again. After loading in the AMA, okay, after loading in the AMA, which is this file, okay, you open your toolbox. You open your Arc toolbox. You navigate to Spatial Analysis Tools. Okay, you navigate to Spatial Analysis Tools. Spatial Analysis Tools, this tool. Okay, Spatial Analysis Tool. You expand it, which gives you these subtools. Okay, these subtools. Another subtools, we want extraction. So, okay, this. Okay, we want extraction, this tool. You expand it. Okay, which gives you this set of tools. Okay, but we want only extract by mask. Okay, we want only extract by mask. Okay, so you select that one, which gives you this window. Okay, which gives you this window. The first window is asking you for your raster data, which is this data. That is the NDVI data you just performed. Okay, so under it, you select raster cal. Okay, which is the NDVI data. Okay, the NDVI raster data. You select raster cal. Can I go on? The second option is what? The input raster or feature mask. Okay. Under the feature mask, you select AMA. Select AMA. Okay, so we have this, like this. Okay, so first the raster cal, and then AMA. So when you are done, you just click OK. When you are done, you just click OK. So it runs and then it extracts your AMA for you. Okay, so you have something like this, right? You have something similar to this, right? You have something similar to this. All right, so let's uncheck the rest, leaving only AMA. I'm just unchecking, leaving only AMA. You uncheck the rest. You can see the tick sign here. You uncheck the rest, leaving only AMA. Okay, so you can see this value. You see the NDVI values. You see the NDVI values. So you can see 0.43 and then negative 0.06. Okay, let's change the color ramp and see what's happening in AMA. So let me change it to a color ramp that I can see the features well. Maybe something like this. Okay, so something like this. Okay, I've changed the color ramp. Okay, so you can see initially the whole of the coastal region was 1 to -1, but now only Accra has between 0.4 to 0.06. Okay, so who can tell us what's happening here? What's happening here? What's happening here? Looking at the NDVI values. What is happening there? Come again? Low healthy vegetation. Okay, you can tell the number is quite small. The vegetation is not that healthy because it's not close to one, right? So we can see that probably if it could be because of maybe built up expansion, or it could be because of the kind of practice that is involved in there, which basically tends to deteriorate the health of vegetation, right? Yeah, so you can see that in here, only this part is quite healthy, but the healthiest is the 0.3 around this side, right? Around this side. But you can see when it moves towards the southern side, the healthy vegetation is what? It's not that significant. So you can see that most of these stuff are being dominated by built up, or we say impervious surfaces. Okay. All right, so that is how we perform NDVI. Okay, so your homework is going to be NDVI for Landsat 7. Okay, NDVI for Landsat 7. That's your homework. So let's move on to the NDWI. Okay, NDWI. So now we are done with NDVI. Before we move on, any question? Any question for the NDVI? It's quite simple, right? It's quite simple. All right, so let's move on to the NDWI, which I said is for water indices. Okay. So in case, so this is for water indices. Okay, water indices. So the more it gets to one, that means there's a lot of water, or there's significant amount of water in that area. And the less it gets to -1, or the more it gets to -1, that means there's no significant water bodies in that area. Okay, so let's do for NDWI. Any questions so far before we move on to NDWI? So let's remove everything apart from the AMA. Let's remove everything apart from AMA. Let's leave only AMA there. Okay, I'm removing, just right click and you click on remove. Okay. But I want to leave only AMA here. Okay. I'm leaving this one here. Let's bring in band 2 and then band 5 for Landsat 4. Okay, band 2. We already have band 2, right? Band 2 and band 5 for Landsat 4. Band 2 and band 5. Do we all have the band 2? We all have the band 2, right? Yeah, so if you just bring in band 2 and band 5, you just bring in band 2 and band 5 for Landsat 4. Band 2 and band 5 for Landsat 4. Okay, let me send the band 2 for Landsat 4 in there so that you download it. So I just sent the band 2, those who don't have the band 2. I think all of us have the band 2, but I'm just sending for those in case you don't have it. So let me give you like 2 minutes to wrap up, then we continue. So as you are downloading band 2, I'll give you 10 minutes to rest, then we continue. 10 minutes to rest, and we continue. 10 minutes rest, then we continue. Okay. It looks good. Yeah. This one is 7.
Yeah.
Looks good. Okay, let's continue. I guess that I gave the Lancer 7 as homework, but I think some of you have done it. So it's you can see that those who did for Lancer 7, it's homework, but I see people have done it. You can see that the NDVI has decreased, right? Those who did for Lancer 7, but it's homework anyway. So let's continue. Now we are doing NDWI, Normalized Difference Water Index. Okay, which requires band 2 and band 5. Okay. So now let's first focus on the first aspect of the formula. It says band 2 minus band 5. Okay, so first let's bring in band 2 and band 5 to ArcMap. For Landsat 4, band 2, band 5, Landsat 4. Landsat 4, only Landsat 4, band 2 and band 5, only Landsat 4. Band 2 and band 5, only Landsat 4. Band 2 and band 5, only Landsat 4. So band 2, and band 5, only Landsat 4, only Landsat 4. So I'm bringing in band 2 and band 5, only Landsat 4, only Landsat 4. Only Landsat 4, band 2 and band 5. So band 2 and band 5, only Landsat 4. Band 2 and band 5, only Landsat 4. Band 2 and band 5, only Landsat 4. Landsat 4. The only calibrated Landsat 4. Should we continue? Okay. Now the same process, okay? So you are going to take me through it. So what do we do after loading in? Yeah, so you expand Special Analyst 2, and then we do what again? Yeah, you expand Map Algebra, and then you open what? The raster calculator. Right, so when you open the raster calculator, you have band 2 and band 5, right? You have band 2 and band 5. According to the formula, it says what? So band 2 minus band 5, okay? Okay, so let's do the first step, band 2 minus band 5 into brackets, right? So we are doing the first step. So it says band 2, first, hold on, we need to open our bracket first. Open our bracket, it says band 2 minus band 5, and then we close it. So we have something like this. Okay, we open our bracket, band 2 minus band 5, we close it. Okay. Then the next step is to what? Do the division. So you bring your divided by, and then band 2 plus band 5. And then you close it. So something like this. So first, band 2 minus band 5 divided by band 2 plus band 5. You close the bracket. Okay. Should I repeat the steps or it's okay? Should I repeat the steps or it's okay? All right, so when you're done, you just click OK. So it will run and then it will give you the results. All right, so you can see that the results here, you can see it also lies between what? +1 and -1. Okay, it also lies between +1 and -1. Let me change the color to any color I want, which depicts water. So for instance, if I pick this one, all right, so you can see that the water areas, right? You can see that these are what? Water bodies, right? So you can see the water bodies are closer to what? To 1. Okay, so you can see that the water bodies are closer to 1. And those which are not water bodies are closer to what? -1. So as we can see in here, right? We can see in here. So you can see that this is the ocean or the water body, and this is the lake, the Volta Lake or the Volta River. And there are some rivers in here or wetlands in there. All right. Any questions so far? Any questions so far? But the problem is you only want this area, right? You only want this area. The area within AMA, right? So what do? All right, so again, we go to Spatial Analysis 2, and then we do what again? We navigate to extraction, right? Which is the fourth tool under Spatial Analysis 2. This extraction. You expand it, and then of course, you go to what? Extract by mask, which is the third option. Okay, so what do we do next? So we choose the input raster, which is the raster, that is the raster calculator, okay? And then we'll choose the AMA, which is this, okay? And then we click OK, which runs and extracts only AMA. So we have something like this, right? We have something like this. So we can uncheck the rest and then change this color around to the first one, which depicts water. Any is fine. But let me choose the same thing so that we compare. Where is my color ramp? This one here. Okay. So from the color ramp, what do you see? What's happening here? This one. Let me just highlight that one. What's happening here? What is happening? What is happening? Looking at the values, what is happening? In terms of water index, like in terms of water bodies, what's happening? We see 0.34 and -0.54. What is it telling us? What is it telling us? What is it telling us? Yes, so we can see that at AMA, the dominant feature is what? Is yellow and some green parts, right? Only the water bodies are concentrated within this side, right? The rest are mostly vegetation and built up, okay? All right, so that is what it is communicating to us. So now you've successfully completed NDVI and NDWI, okay? NDVI and NDWI. Any questions so far before we move to the last aspect that we close, which is the most difficult part, the temperature analysis? Any questions so far? Any questions so far? Any questions so far? Okay, so I'll give you like 3 minutes to wrap up, then we look at the last one, which is temperature analysis. 3 minutes to wrap up, then we look at the last one. Okay, so for your second homework, you do that of Landsat 7, NDWI for Landsat 7, your second homework. So first homework is for NDVI for Landsat 7, second homework, NDVI for Landsat, NDWI for Landsat 7. Okay, let's move on to the last part. Okay, let me clear everything here and leave only the AME. The last part is the temperature analysis. Okay. The last part is the temperature analysis. Which is this. Okay. So initially we looked at how the landscape has changed across time. So we use a case study whereby your supervisor wants you to look at the effects of, let's say, temperature, so the effect on land use land cover changes to temperature analysis or to temperature. So first we looked at how the landscape have changed from 1991 to 2021. We also went ahead to do some few change detection analysis to see that, yes, indeed, it has changed and the driving force is built up, whereby we are replacing natural surfaces with impervious surfaces. Then we saw that another change detection analysis, we saw that the dominant feature which absorbs most of the other land classes is what is built up. We advanced to do the map, the land use land cover change map. Today we looked at the health of vegetation, which is NDVI, and we also looked at water indices, which is NDWI. The last aspect is to look at temperature. Okay, so we are going to look at how temperature has changed. We are going to do, because of our time, we'll do only Landsat 4, and then Landsat 7 will be your homework. Okay, Landsat 7 will be your homework. So, in doing temperature analysis, in Landsats 4 and 5 and 7, we normally use 6 for the temperature analysis, band 6. So band 6 is the thermal band, okay? It's the thermal band in temperature analysis. And before you do temperature analysis in ArcMap, you first need to do what? Calibration. Remember, we did calibration. Okay, so the calibration we did, the back end, this is what we did, okay? At the back end in ENVI, this is what we did, okay? So we are coming to do the same thing in ArcMap. Okay, so this is basically the formula for calibration that we did in ENVI. Okay, but we use the software, just click, and then we got the answer, we got the calibration. But this is how it does at the back end. Okay. And all of these are in the metadata file. The values are all in the metadata file. Okay, so before you do temperature analysis, you have to do what? Calibration, where you convert the digital number, that's the image, to what? Radians. Okay. What we did was for reflectance. If you remember, when we were doing the ENVI, when we were using the ENVI, and we did calibration, okay, let me just pick any file in ENVI. Let me just pick this one, for instance. And we did calibration. We selected this, right? So if I zoom, you can see that under here, okay, we selected what? Reflectance, right? Right. So in this case, you can go to ENVI, but in this case, you select what? Radians, right? But we are going to do it in ArcMap because we've already done it with ENVI already. So in ArcMap, this calibration is what's represented here. Okay, so this is the calibration we did. Okay, this is the calibration we did. And as I said, in ArcGIS, we are going to also use the same raster calculator, right, to do what we did in ENVI. All right, so first, we are going to bring in our band 6. And band 6, there are two types of band 6, which is the band 6.1 and then band 6.2. You can perform it on any of them. But we are going to perform, in this case, on band 6.2, which has high gains, okay? Which has high gains. But all of them are all thermal bands, okay? So we are going to utilize only band 6.2. So when you open your folder, that's Landsat 4 folder. Let me make these images bigger. Okay, good. When you open bands, when you go to, you can see I have band 6.2.1 and then band 6.2.2. Let me see. I think Landsat 4 has only one band 6. Okay. Anyway. Okay, let's utilize the band 6 in Landsat 7 rather. Let's go to band 6 in Landsat 7. Let's make this one rather big. Band 6. Okay, so you have band 6, these two, right? Okay, so you have these two. You can see that band 6 VCID1 and band 6 VCID2. Okay, you can see, right? So we are going to make use of this. You can use this, but I'm going to use this. Okay. So band 6 VCI2, VCID2. Okay. So the problem now is that you can see that there are still scan lines in band 6, right? So you need to remove them in ENVI because I don't have the extension in ArcGIS yet. So we are going to remove only the scan lines before we continue the calibration. Okay. So let's load band 6, Landsat 7, band 6.2. Okay, 6.2. If I say 6.2, I mean 6 VCID2. Okay, let me clear this one. And then let's do it quickly. I know our time is fast spent. Okay, so I'm going to open band 6.2, VCL2, this one, the second one, okay, this one. See this one, the one with the VCID_2. You can see that it has what? Scan lines in there, okay? It has scan lines in there. So you have to remove it first before you continue the analysis. We've done this already, right? So I'm just rushing through. So let's remove the scan lines. Of course, extension, build, and gap fill. You save it in your calibration folder. Sorry, in your gap fill folder. I'm just going to name it band 6 B6 _2 because I'm doing B6 _2. We've done this already, so I'm just rushing through. I'm just cleaning the scan lines, which we did some few weeks ago. Okay. So we just apply scan lines to it. Okay, so that's what we are doing. Let's go back to ArcMap. Let me send you those ones so that you just use it. I'm sending you those ones, the one I just did. band 6 gap fill. So I just sent you the band 6. You can just download it so that we just continue. The one I just did the listing on. Gap fill on. Let me just give you some 1 minute to bring it into the ArcMap. When you're not downloading, bring it to the ArcMap. I'll just give you like some 2 minutes to do that. Are you done downloading? Okay, now let's proceed. Okay, so according to the formula in here, it says that converting from doing the calibration, okay, you need this, okay, this formula. Okay. Everything in here is in the metadata. Okay. Everything in here is in the metadata. Okay. So the first step is that to calibrate the thermal band, okay, let's look at this first. It says what? Okay, L means radians. So the radians maximum values minus the what? The radians minimum value. Okay. To do that, you go to your metadata. Okay, the answer 7 metadata. Okay. When you scroll down a bit, okay, when you scroll down a bit, you see this in there. Okay, you see this in there. Okay, okay. So you can see L max is what represents radians max. Okay, so we are looking at what? Band 6.2, right? 6.2. So is this one, these ones? These two, yeah. These ones. Okay, so L max represents what? Radians what? Maximum. So you can see that the radians maximum value for 6 VCID is what? 12.650. And the minimum radians, the radians minimum value for band 6 VCL2 is what? 3.200. Okay. So that's what we are going to do. Okay. I'm repeating again. In the formula, it says that what? L max, this L represents radians, okay? So converting the digital number, which is the image at its current state, to radians, you need what? The radians maximum value number minus the radians minimum value number. And in the metadata file, the radians maximum number is what? The maximum number of the band is what? Is 12.6050, right? And then the minimum is 320. Is that clear? It's quite clear, right? So let's do that now. When you go to the ArcMap and you bring your image in there, okay, same process, you go to the raster calculator, okay. First, as I said, same process, you expand the spatial analysis tools, you expand math algebra, and then you open raster calculator. Okay, so you have your band 6 displayed in there, right? The gap fill band 6, okay. Right. Can we continue? Okay, so you can just copy the value, okay, of the maximum. You copy it, you open your bracket, you paste it in there, something like this. Okay. If you can't copy, just type 12.650. It's fine. The next step is what? It's the formula says minus, right? Right? It says what? Minus. We are doing only the top. Okay, we are doing step by step, only the top. So L max minus L min. The L min is what? 3200, right? 3.200. So you can either copy or you can just type it there. So you copy it or you can just type it there. Minus that. And then you close the bracket. 3.200, sorry. 3.200. So the maximum is 12.650, minimum 3.200. Okay, so now we are done with the first step. Okay. We are done with the first step. So you close the bracket with the first step. Okay. You close the bracket. So like this. Can we continue? The next step is what? Let's look at the formula again. Divided by the quantized. So the Q represents the quantized maximum number minus what? The quantized minimum number, which is also in the what? In the metadata. So you go back to the metadata, we look for the quantized. This one is Landsat. Okay, let me just close this one. All right, so we scroll down a bit and we see what quantized in here, right? We see quantized. So we can see the quantized values, right? So you can see that the quantized, okay, the quantized calculated maximum is what? 255, right? And the quantized minimum is what? 1, okay? So you do that in the, so you bring your divided by, you open another bracket. So you said what? Quantize what? Maximum minus what? Quantize what? Minimum, right? So that's the formula. Okay, max min. So 255 minus what? Minus 1. Minus 1. You close your brackets like this. Okay. So step by step, the first process is to what? The radians maximum minus radians minimum divided by quantized maximum minus quantized minimum. Can we continue? It's quite okay. The next one, it says what? Multiplied by the DN number. Okay, so the DN number is the band 6 capsule number now. Okay, so the DN represents this one. Okay, the band 6 in here. Okay, the DN, the digital number is the band 6, which is what? Between 194 and then what? 0. Okay, so we bring what? Multiplication. Times here represents this. This represents times. Okay. Multiply. This icon represents multiply. Okay. So you click on it. Okay, and you have something like this. Okay, you have something like this. And the formula is saying what? Multiplied by what? Into bracket the DN number, which is band 6, gap fill band 6, minus what? The quantized minimum, which is this one, which is 1. Okay. So you double click, you bring your into bracket first, right? And then this is the DN number. Okay, you double click it, then minus the lower distance 1, which is 1, right? Something like this. Okay, so as I said, the DN number represents the band 6 uncalibrated. Okay, minus 1, which is the quantized minimum number. Okay, for the band. Any questions so far? Should we continue? You shouldn't continue. Our time is fast spent, so we need to be very, very fast. Okay, so per the formula, we can see that we've gotten to what? So we did L max minus L min minus quantize max minus quantize mean multiplied by the DN, which is the band 6 itself, minus the L quantize what? Minimum, plus what? The minimum, which is what? 3.200. Okay, which is a 3.200. Yeah, so the minimum is the same here, so 3.200. So you add it to it. It says plus, right? So you bring your plus sign and then 3.200. So you have something like this. Okay. So L max minus L min, all divided by quantize max minus quantize mean, multiplied by the DN number, which is the band 7, band 6 itself, which is the DN number, minus Q, what? Quantize minimum, which is 1, plus what? Radiance minimum, which is 3.200. Are we clear? Okay, so when you're done, just click OK. So it runs and gives you something, the results. This is just calibration. We've not done the temperature analysis yet. This is just calibration. In ArcMap, this is just calibration. So it gives you something like this. Okay. So what's the difference between this and this? What's the difference? What's the difference? What's the difference? The high value and the low. So what does it mean? This takes you back to the definition of calibration. What does calibration is? Who remembers? What's calibration? What's calibration? Can I share? Who remembers? What's calibration? What's calibration? Mr. President, your people say they forgotten calibration. Or should we buy a cane from Pindodo? All right, so calibration, as I said, is the removal of all distortions, okay, all errors. So at first, there were errors on the image, and we've removed all the errors. That's why we see what lower values, right? So we've removed all the errors, such as aerosols or any particles in the atmosphere, which distorts the image. Okay. So we've removed all of them. Okay, so now we've done calibration. The last one is to do the temperature itself. So first, we are going to do the temperature in Kelvin, and after that, we go to degrees Celsius, okay? So to do the temperature in Kelvin, this is the formula which was introduced. Okay, so temperature in Kelvin represents what? The K2 divided by the natural log of K1 minus what? The calibrated image we just did, plus 1, okay? In Landsat 7 and Landsat 5, the K1 values has been given here already. Okay, so you can see K1 in Landsat 7 is what 666.09, right? And K2 is what 1282.71. Okay. However, Landsat 8 and Landsat 9 is different. Okay. Landsat 8 and Landsat 9 is different. Okay, so please remember, Landsat 7 has a different constant figure from Landsat 9 and then 8. So please remember. Okay, so Landsat 8, you see that K2 in here is what? It's 1282, right? And a Landsat what? 7, 1282.71. And then K1, okay, represents 666.01. Okay. For the natural log, it's already in ArcMap already. Okay, it's already in the Raster calculator. And we've already calibrated this already. We just did this right now, right? So that's what we're going to do. Is it clear? Okay. Now let's do that. So we still open the Raster calculator, right? We still open the Raster calculator. Now the formula says what? It says K2, okay, and then K2 is what? 1282.71, right? 0.71. Okay, K2. This one. This one. So K2, as you can see in Kelvin, is what? 1282. Okay. You can write it down somewhere. I even sent the file. So all right. So now let's do that right now. So we can open our bracket. Okay, you can open our bracket. And then it says what? 1282.71, right? Let me confirm. Yeah, so 1282.71, right? Okay, let's close our bracket. Okay, that's the first step. The first step is to type the value of K2, which is 1282.71, right? The next step is to do what? Is to divide it by what? The natural log of what? K1, right? Over the radiance calibration we just did, right? So K1 in here is what? K1 in here is what? It's what? 66.09, which is this one, right? So we are going to do that. But before that, we need to what? Add a natural log, right? You can see another conditional here. Okay, another conditional here. Okay, you scroll down and you see ln, which is a natural log. Okay, you scroll down. So when I scroll down, I see ln in here. This one. I see ln in here. Do you see it when you scroll down a bit? ln. Do you see that one? Okay. You double click on that. Okay, so it says multiplied by, right? Or is it divided by? Okay, so divided by this one, right? And you double click on your natural log. So you have something like this. So divided by the natural log, which opens an automatic bracket for you, right? Right? Okay, so it says what? The K2, right? Or K1. K1, right? Which is 666.09. All right, so let's do that. So in the bracket, we type 666.09, right? Let me confirm. Yeah, so 666.09, which is this one, right? Okay, then it says what? Divided by what? The radians. That's what we just did, which is this one, right? That's what we just did. So we bring what? Divided by, which is this one. We bring divided by, all in the bracket, right? Divided by, which is this one. And then remember that the results we've gotten was this from the Raster calculator, which is the C12, right? That's the results we've got. So you double click on that, like this, and you have something like this. Okay, so we have the K2, okay, divided by the natural log of what? K1 divided by what? The radians band we just calibrated. This is this. Okay. Is it clear so far? Is it clear so far? Now, the next step is that the formula says what again? It says what? +1. Okay. So you continue with it and then you just type in here +1 like this. Okay. So you have what? K2 divided by the natural log of K1 divided by what? The radiance band +1. So this is what you are going to arrive at. This is what you are going to arrive at. When you're done, just click OK. So it runs and it gives you the temperature in Kelvin. Okay, in Kelvin. Gives you the temperature in Kelvin. Okay, so in Kelvin, we have what? This value there. Okay, so in Kelvin, we have what? 332.08 and then 239.548. This is in Kelvin. This is in Kelvin. Do you have the same thing? Oh, I know someone will get errors. It's normal. It's not. How many of you got 322.08? Okay, so that means some of you got it right. But the thing is that our time is fast spent, so the recordings will be posted there so that you go through again. The error comes because the equation, you didn't type in the formula or in the equation bar when you are doing the raster calculator. So the last step is to convert to degrees Celsius. Our methodology is how do you convert Kelvin to degrees Celsius? You minus what from what? Come again? Yeah, 273.15, right? Yeah, exactly. So it's the same application. So in our formula here, you can see we indicated here that what to convert to degrees Celsius, you need to what? Multiply 273.15 from it, right? So that's what we are going to do. So currently we have it in Kelvin, right? So let's do that quickly, then we leave. Same process, raster calculator. By this time, you can see that you have what? The new Kelvin image, right? Which is this one, the new Kelvin image, which is at the top, right? So you just double click on it and then minus 273.15, right? Like this. Something like this, right? So the temperature is in Kelvin now, so we are converting it to degrees Celsius. So you need to subtract 273.15 from it, right? Right. So when you are done, just click OK. When you're done, just click OK. So it runs and then it gives you your results. All right. Okay, so we can see that it has given us something like this. So the highest temperature is 48 points, and the negative, yeah. This is high because of the water bodies. It shouldn't be negative, but so we need to extract our steady area from it. Right? This is too high because of the ocean in here. Or the ocean is quite very, very cold and stuff. So we need to extract. When we extract our area of interest, we'll know the actual distance. So if you give it a color ramp, if you give it a color ramp of a temperature, something like this. Okay, let me invert it. Something like this. So you can see that the ocean is much more colder, right? And so we are going to extract our area of interest, right? Which is this area. Okay, is this area. So you are extracting only AMA. Okay, AMA. It's the same process as we did. So how do we extract AMA? How do we extract AMA now? The same process. How do we do it? How do we extract AMA? Okay. Yeah, you go to extraction and then exactly extract by mass. You select the degree Celsius image and then you select AMA, right? You click OK. So it does it and then it extracts only AMA. It does it and it extracts only AMA. All right, so now let me uncheck the rest and then see what only AMA is giving me. Let me extract the rest and then see what AMA is giving me. All right, so this is what AMA is giving me. So this is the temperature in degrees Celsius. So you can see that the highest one is almost 30 degrees Celsius and the lowest is 21.41. So this is how we perform temperature analysis. Okay, this is how we perform temperature analysis. This is how we perform temperature analysis. You can choose any color ramp. If you want to choose any color ramp, you can just choose it. You can choose any color ramp. All right, so you can see that the vegetated areas are much more colder or are much more moderate as compared to the built-up area. So these typical built-up areas, which is quite hot because of the impervious surfaces, which tends to trap heat and release them at night as long wave radiation. Okay, so this brings us to the end of the indices and temperature. So tomorrow, we are going to look at the study area, how to create a study area map. Then from next week, the next presenter comes in, or the next teacher comes in. All right, thank you. See you tomorrow.